Hello everyone, and welcome back to another IB Math Speedrun with me, Vince. So today, we finished Unit 2.2 and we're on to Unit 2.3 of the IB textbook, which concerns ourselves with classifying functions. So let's jump right into the exercises. So, what do we need to know before completing the exercises? First of all, we need to know the four types of mappings for a function. So this actually not for a function, sorry, but for a relation. And so this helps us classify these different relations. So the first relation we have called see this is a map of a relation. We have some set A over here and some set B on this other side. And using this diagram, we can express the four different classifications of relations. So the first one is called a one-to-one. So it's 1 to 1. And what this means is that every dot in A maps to exactly one dot in B, like so. And yeah, so it can look something like this. If you follow the path from every dot to A to a dot in B, you can see that there is only one path between the two. And so this is a function. Now, let's move on to the next relation that we will be looking at. So we have the four dots again. And I'm not going to bother drawing out the A and B, but the next function we are interested in is a many-to-one function. And this is when, yes, it's the same as this diagram, where one dot from A maps out to one dot in B, but this time, looking at it, one dot in B maps out to many dots in A. So, sorry, the difference, a one-to-one function is when every dot or point or object in A maps to exactly one object in B, and every object in B also maps to exactly one object in A. Therefore, it's a one-to-one relationship. In a many-to-one relationship, every dot in A still maps out to only one dot in B, which is why we say one, but many dots in A map out to the same dot in B, which is why we say it's a many-to-one relationship. And so these two relations are functions. And we also want to look at two relations that are, two classifications of relations that are not functions. So the first one we're going to look at is, let me draw it out again, is called the one-to-many. And it's important that you don't get this confused with the many-to-one. So the one-to-many is when each dot in A, sorry, how would this best be explained? It's when each dot in A can map out to multiple dots in B, but each dot of B can only map out to one dot in A. Oh. So, like here, we call it, first of all, a one function because each dot in B only maps out to one dot in A. But we call it a many function because each dot in A can map out to many dots in B. So it can be seen as the opposite of this many-to-one function. Finally, we have the final function. And, hold on. I'll draw it here because I have space. This is called a many-to-many function. And what this means is that many dots in A map out to many dots in B, and many dots in B map out to many dots in A. So it's like a combination of these two functions. And so as you can see this dot here, this maps out to that dot in B, that dot in B, and that dot in B. And this dot here maps out to that dot in A, that dot in A, and so therefore it's a many-to-many. Okay. Now that we have got that covered, we need to talk about one final classification of a function, and that's called an onto function. So, taking our sets of A and B, a function is called an onto function if for every element in B, there is at least one element in A that maps to it. So for example, I missed the line, but for example, this is an onto function because for every element in B, there's at least one element in A that maps to it. This is, sorry, let me draw it out again. This is this is also an onto function for the exact same reasons. And say we remove this bottom dot from B. This is also an onto function because for every dot in B there is at least one element. So in this case, at the bottom here, there is more than one element that maps from A to B. But it doesn't matter. It's just as long as there is at least one element that maps from A to B, it is an onto function. Now, what's an example of something that's not an onto function? Well, say we have an element here that's part of set B, but no element in set A maps to it. This would then not be an onto function since not every element in set B is mapped to for at least one element in set A. Okay, I think we've got that all covered, and so I think we're ready to tackle some problems. So for all of these problems that we'll be discussing, we need to simply determine whether the functions are onto, one-to-one, neither, or both. So I'm going to do even ones this time. This is our function, and this is the x-axis, and this is the y-axis. And the domain of this function is for all real numbers, and the range of this function is for all real numbers. If you haven't seen this notation before, this is shorthand for the domain, and this is shorthand for the range of the function. So we can see that the domain is for all real numbers and the range is for all real numbers. So, is this function an onto function? The answer is yes, because for every element in the range, which is all real numbers, there will be an element in the domain that maps to it. For example, for this point here, which is 1, 1, well, the element of 1 maps onto the element of 1. For this point here, say this is 2, 8, well, the element of 2 maps onto the element of 8. And for every intermediate point, since this is a curve, there will be some number on the curve that maps to the y value at that point, since it's a continuous curve and will go on for an infinite amount of time. So it's definitely an onto function. Now we need to test whether this is a one-to-one function. And the simplest way to do this is to do the horizontal line test. It's different to the vertical line test, which we use to test if a relation is a function, but the horizontal line test tells us whether a function is one-to-one or not. If a function is one-to-one, we should be able to draw a horizontal line anywhere on the function, and it should never intersect more than one point, which means that there is only one x value for that corresponding y value, and therefore it is a one-to-one. Now, if we had a slightly different function, something like this, then like that, well, then we would be able to draw a line here and say, oh, okay, well, it intersects there, but it also intersects there, and so therefore it can't be a one-to-one function. But in the case of this function, it is also a one-to-one function. So we know this function is both an onto function and a one-to-one function. So let's go to the next function. The next function is expressed in this kind of set form instead. So we have the elements 1, 2, 3 here, and D, B, C, A. And what it's saying is that 1 maps to D, 2 maps to B, and 3 maps to A. So first of all, is this an onto function? No, clearly not, because there is an element right here that is not being mapped. There's an element in Y that's not being mapped from any element in X. And remember, an onto function has to have all the values in the range mapped to at least one value in the domain. So this is not an onto function. But is this a one-to-one function? And the answer is yes, because you can see for every element in the domain, it maps to one and only one element in the range. And so therefore, it is still a one-to-one function. Okay, now moving on to the final function for this challenge. We have a graph that looks something like this. Close dot there, open dot here, close dot there, open dot here up. Okay, and this function is valid for all values in the domain of real numbers to all values in the range of positive real numbers with the union of 0, which means this is all real numbers that are 0 or positive. So, is this function an only function? The answer is yes, because to test whether a function isn't an only function, there has to be some values of y in the range that there are no x values for. And in this case, since the range is all positive numbers and 0, we can see that the graph clearly extends for all positive numbers and touches 0 right here, and so therefore it is an only function. Is it a one-to-one function, however? And the answer is no, because doing the horizontal line test, we can draw a horizontal line right here and see that there are 2 points that intersect the horizontal line, and so therefore there are multiple x values for at least one y value. And so therefore it is a many-to-one function. Okay, that was it for this exercise, and I hope that you're now confident in classifying functions, and I hope to catch you in the next speedrun today. See you!